So today we'll understand the method multi-zone method. Okay. So in the multi-zone method, what basically we can do is we can create a hex cell. Okay. How we can create a hex cell? There are two more methods along with the multi-zone method where we can create a hex cell. So first swap method and thin swap method. Okay. Now is a multi-zone method. In this also we can create a hex cell. How we can create, we have to check first how many bodies do we have only one body. Okay, for swap method what we have a one body and single source and single target we require. That's on that part we can create a hack cell, and that is a fulfilled requirement of the swap method. In second method, thin method, where we have a thickness of side faces are very much less, over there we can apply the thin swap method. Okay, but in that we can select the multiple source and multiple target. Okay, what is the meaning of multiple source and multiple target is that if you can see, we can have a one source and one target. Okay, one source, one target. Here also we can select one source and one target, and this one source and target. So it has also multiple source and multiple target, but only one body. So as per the swap method, we require, if there is one body, we need a single source and single target. But multi-zone has given that facility that with the one body and multiple source and multiple targets are there, we can still achieve the hex element. Okay, so how it will do in a background is that in the multi-zone method, the background step is that it divides the geometry as per the source and target. Okay, so it divides the geometry as per source and target and create a hex cell. Okay, let's see the experiment how we can achieve the first we have to change the physical preference to CFD. Okay, and then solver to the fluent. Okay, then select complete geometry using the method. Okay, and then give a multi-zone method option. Okay, so in multi-zone method, first of all, let's go strictly directly we'll go to the single source and target selection. That is first important part. So source and target selection is right now automatic, but you can still have a manual source and manual target. If you are very much confident about the manual source selection, so we can go for that option. Otherwise, ANSYS will help us to select automatically source and target. So I will show you the hard part, hard method, that is manual source. So we can select this as a source. Okay, then in a backside we'll select this as a source, and again we can select the this source bar. Okay, which will be pop up over here, and the this source bar which will be pop up over backside, and this one will be pop up over this side. Okay, so one source I have selected, this, this, and this, and this. So this part will be our source part. Okay, and we have selected this, and then you can also give us the shape size behavior, like what should be the side faces. Okay, so that part you can control later on, like what should be the element size. Okay, so you can control from this part. Okay, if you want a finer mesh, you can queue this less element. like less element size, so that you can have a more finer mesh. Okay, and then generate the mesh. So right now you can see you have a good hex element. Okay, how you can see that? Yes, hex element has been generated. You can see from the quality, mesh matrix, skewness. So you can have that. Yes, so this is hex 8 means hex element. Okay, and the skewness is point less than point 0.4. So which is a good mesh. You can again reduce it to the less element size. Okay, by giving a direct general, you can give a global element size. Right now it's 1 e to power minus 2. We can keep it as a 0.5 e to power minus 2 and then generate the mesh. So still you can see it has been reduced to zero point 0.4. So this is much more better mesh as per the CFD. And see, you can see that this source have a same on a target, and same element, or we can say s- similarly mesh what form get over here. You can see at the target also similar from this side. So to the this side we have a same mesh, and then on side faces over here you can have a see, you can see that all are the hex element. Okay, so basically after this you can pen it and identify the element, is it's a hex element or not. I will just zoom on that part. Okay, box zoom. This is the element that is called hex element. Okay, and once you have hex element, the number of cell count also decreases. Okay, you can see that part into the statics. So it's only 9,000 element, although the geometry is smaller. So that's why the element size is. Now, if you have a tet mesh, okay, so you can see what is the difference in a skewness. So basically, if I select over here and give as a tetrahedron mesh, okay, and suddenly you will see that from 9,000, the element size will increase. Sorry, the element number of element count will increase, and as well as the skewness. We'll see what will be the difference. So I have given the tetrahedron. Okay, so you can see that element has increased the skewness, which is very much bad thing. Okay, means it's not a correct mesh. And as well as see, you can see for same geometry you got 40,000 element, means your computer time for doing calculation increases, as well as the bad element will not give us the good correct reliable results. So this is the one thing. So it's always good to select the multi-zone, and once you have multi-zone method, you it will be useful, and we can rely on that. And source should be, now you can select the source as a automatic. So that is also useful, and then generate the mesh. Okay, after this once you have a this mesh, you can also put a inflation. You can select the method and inflate this method. The body has been selected. Now if this as an inlet, okay, and this also as an inlet, okay, so basically we can select the side faces. Okay, we can select the side faces so that we can have a good mesh on the wall, which is so we have good inflation normal to wall. So if I'm telling that this is as an inlet and this as an outlet, okay, and this is all acting as a wall in your real simulation scenario. So what we have to select all the walls except that inlet and outlet. So I will select this face, this face, this face, this face, and this face, and this one. So you can create an inflation. Let's keep the inflation properties as a default and generate the mesh. Okay, so now you can see hex is continued, and you have a good inflation layer at this part. Okay, which is inlet and outlet. And when I do a when I do a section plane, when I generate a section plane, so you can see along the walls you have a pro inflation layer, means that near the wall you have a smaller element, and as we go away from the wall we have a more bigger element size. So that is what CFD is also. We always go for boundary layer resolution. So this is what we can see in this the geometry. Hope you understood the multi-zone method. Thank you.